Okay, converting hexadecimal into denary. There's actually two methods in this video that I'm about to show you. You can choose whichever you find easiest. So method number one is to convert this hexadecimal into binary, and I've got a video. If you're unsure, you can go and watch it. And then once you have that binary number, you then convert it to denary. And again, there's a video if you're unsure, go and watch that one first. So if we convert this into binary first, we're going to take 5 and we're using the column headings 8, 4, 2, and 1. So 5 would be 0, 1, 0, 1. We're then going to take E, and we know that E is equal to 14. So right next to it, we're going to write the binary number for 14. So that's 8 plus 4 plus 2, and that's a 0. So that's the binary answer. But obviously we then want to do the extra step, which is convert it into denary. So that would be 128, 64, 32, 16, 8, 4, 2, and 1 as a table. And we would place our binary number into this table. So that's 0, 1, 0, 1, 1, 1, 0. And then we do our conversion. So that's 64 plus 16 plus 8 plus 4 plus 2. And that gives you 94 as your answer. So that's method one. So convert the hexadecimal into binary, then convert the binary into denary. Okay. Now, method number two, the other way that you could do this. So we're going to take 5e. And before I start this method, there's just one quick explanation that I just want to show you. So if we're using denary, and this is probably a method that you've been taught since you were very young, is that you use a units column, a 10, 100, and a 1,000 column. And to make any number, that would be your starting point. Okay. And then we started to look at binary, and we said that there is a units column, there is a 2, a 4, an 8, and so on, 16, etc., etc. Okay, and we created a table for that, for our binary numbers, and we were able to put our values in there. Now, the one thing you need to understand here is, how do these tables come about? Well, denary is base 10 digits. So we start with a unit and we multiply by 10, and then we multiply by 10, and we multiply by 10. And binary is base 2, so we start with a units column as always, and we multiply by 2, and we multiply by 2, and multiply by 2. And you can keep going, you can get multiply by 2 to get 16, okay? Now, hexadecimal actually follows something very similar, if not the same. So it starts with a units column, and there is then a 16 column and a 256 column. And again, like the others, it can keep going. How do we get this? Well, it starts with units as always. And because it's base 16, there's 16 digits in hexadecimal, we're timesing by 16. And if you times that by 16, you get 256. So important to know this method, okay? Now, if I just take all this away for a minute, we're going to be using that table that I've just shown you, okay? So there is a 256, a 16, and a units, and that's the table that we need for conversion. Okay, So there's an E in the units column and there is a 5 in the 16 column, and we don't have a third digit, so we can just leave that one blank. So the method is you put your hexadecimal number into the table and then you just multiply out. So that will be 5 multiplied by 16. That's the first one. And we're going to add that to E multiplied by 1. And then you just solve that. So 5 times 16 is 80. And E we know is 14. So 14 times 1 is 14. And then your answer is 94. And that's the second method. One step, put it into the table, multiply, add them up. Or you can go with method 1, which was to convert to binary first and then convert the binary to denary. Whichever you choose, you will get the correct answer.